Right, welcome back to chemistry. We're pretty much done right at the end now. It's been a long haul. I hope that you've enjoyed it. I hope that we've got some good concepts in there. The last one here, hope you've got a pen, pencil, piece of paper. Really, it's worth taking down this little thing I'm going to show you. It's useful, as I said, it's the recipe. It's how you do these things. We are going to go on. I'm going to do another one over here. I'm going to say, let us say, they say, what happens if this? Say that we determine that a compound has a molar mass, okay? Molar mass of 88 grams. Oops, not grammies. 88 grams per mole. This is experimental. Experimentally done. Okay? We do an experiment and we find that 1 mole of this stuff, okay, whatever it is, this 1 mole of this stuff, okay, has got a molar mass, molecular mass of 88 grams per mole. Right? And they tell us that the percentages it's made up of the following. So what have we got? We've got this block over here, okay? This stuff here. It weighs 88, sorry, I'm using weighs. It's mass of 88 grams in 1 mole of the substance, okay? This is made up of the following. Made up out of this. And they tell us that it's made up out of carbon, hydrogen, and oxygen. Okay? And they say as follows. Carbon is 54.5%. Okay? Whoa, hang on. This is remember, we write down the elements. Okay? The percentage. Change it to grams, right? Molar mass and N. Number of moles is equal to mass over molar mass. Remember this? Okay, well, here's a little table. Let's see if this works. So we write down the percentages first, right? The percentages are 54.5, 9%, and 36.5. Okay? What did we do? We then converted it to grams, didn't we? We said, right, remember that is a total of 100%. We now make it 100 grams, which means that's 54.5 grams, 9 grams, and 36.5 grams, right? Molar mass, let's look up. What's the molar mass of carbon? 12 grams per mole. Hydrogen is 1. And oxygen was 16 grams per mole. Right? Okie dokes. So now what do? We say, okay, therefore, let's now work out what N is. N comes out to be, how do we do it? Mass over molar mass. Okay? 54.5 over 12 is equal to, and here's our ratio, is 4.542. Okay, 9, which was 9 over 1. Okay, and over here was 36.5 divided by 16. And we said that's 2.28. And 1, 3. So we've now got a ratio. Okay, we now have a ratio, and our ratio is CHO 4.54, 9, and 2.28. Well, that's a bit of a mess, isn't it? We divide through by the smallest one, correct? So we divide through by 2.28. All right? Because we want to simplify it, okay? Let's just get back to black. So let's see, 2.28, well that's a 1. 9 divided by 2.9 divide 2.28. Whoops, 9 divide 2.28 is going to be equal to 3.95. Okay, can you see the ratio? 4.54 divided by 2.28 is going to be equal to 1.99. Right, can you see here what I said earlier? You don't always get neat numbers all nicely packaged up. You do get numbers that are a little bit sort of, that's more of reality in a laboratory. That's what you're going to see, okay? Those of you doing chemistry and chemical engineering, these are the numbers you're going to see. Well, we round it off to 2, 4, 1, which means C2H4O, right? Correct? And therefore, we now check what is the molar mass of this. All right? Right, let's just go up. How do we work out molar mass of this? Well, we say C 2 times 12 equals 24 grams per mole, right? H is 4 times 1, 4 grams per mole. O is how many? We've only got 1 times 16 is 16 grams per mole. So the molar mass of C2H4O is going to be equal to, let's see, 24 plus 4 plus 16 equals 44 grams per mole, right? But whoa, hold on, whoa. This that we've just worked out here, okay, whoops, I've lost you. Come back, okay. So what we said is that this stuff here, which we had was C2H4O. C2H4O has a molar mass of 44 grams per mole, right? But remember, the block that we actually worked with there had a molar mass of 88 grams per mole, which means the molar mass of the empirical formula that we worked out, this is the empirical, remember? The molar mass of that guy was 44. That was the percentages that we worked out. So the basic form is C2H4O, but that only weighs 44. The stuff we've got is 88, okay? Therefore, it must be C2H4, Kevin, H, not 8, H4O. I need to have 2 of them because the mass of this is 44 grams per mole, right? Therefore, I need 2 of those, all right? Each one, I know I haven't got enough here, but each one C2H4O weighs 44, but the actual weight of the stuff is 88, which means I've got to have 2 of them together. So 2 of them together means I've got C4H8O2, right? I've just multiplied them by that. If you go and work out the molar mass of that guy, you will find it is 88 grams per mole. All right? Just so that you can see, I mean, please note that I am for a purpose doing grams per mole like that. It's also the same thing as grams times mole to the -1, isn't it? Because this has gone up and becomes a -1 exponent on the top. Okay? Right. Straightforward. So what do? Well, we do exactly what we did before. We've got our percentages. Okay? We write down the elements. Let's just go through the process. We write down the elements. Let me just highlight here in green. We write down the elements. right? All of the ones they tell us that it's made up of that stuff. Then we write down the percentages that they tell us, right? This is the same as doing the empirical formula. Then we change the percentage to grams, the same number, because we total, check that they're 100%, okay? In many, many cases, there's a typo in there. It doesn't add up to 100, all right? So just check and make sure it does. Those become the same number of grams. We always go to molecular mass. Work out the molecular mass of the element. Remember, if it's an O, it's only 16. We don't use 32 because it's a single O stuck in with two other things. Okay? Right? H2O. There you go. One O with two H's. So we only use O, okay, when we're doing these things. The next one we do is we say, right, we then calculate N equals number of moles, right? And we calculate that and we get a ratio. We put our ratio down, dividing through by the smallest number and get them in those terms. If we got a half, we convert them to a fraction and multiply through by the denominator. So if, for example, we got if we got 2/3, we multiply through by 3 each item, right? Okay. Then, when we've done that, the next thing is we put down that and we calculate the molecular mass of it. All right? Because they've told us above, we've now got the empirical. This is our empirical. Okay? That's from the percentages. But we have to now go and check the actual weight. Mass, rather. I keep using weight. The actual mass. We have to go and look at it, don't we? Okay? So we go and we look at the mass. And we look and see how many times are we exceeding it. It's 2 in this case, right? So then we multiply each by 2. All right? Good. Now, next. The next one is water of crystallization. Okay? There's a whole load of those there, the water of crystallization. But let's have a look. What is water of crystallization? Well, the classic one that you get 9 out of 10 times is this guy. CuSO4NH2O. Okay? Usually, this is a 5. Okay? What does it mean? It means that we've got copper, sulfur, oxygens, okay? 1, 2, 3, 4. We've got something that looks like that, okay? We've got oxygen, 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 and a copper stuck onto the sulfur there, okay? Like that. Don't worry what it looks like. It's not critical, right? But there, that atom, that molecule there, has got stuck all around it, okay? Whoops, not green, blue. It's got 1, 2, 3, 4, 5 H2Os. Okay? It's got 5 H2Os that are just stuck to the surface. Okay? They're not bonded internally to that. They're just stuck on the surface. Okay? So that water, right, is water of crystallization. What does that mean? It means that when it formed, it took water out of the atmosphere and it stuck the molecules of water, 5 of them, on the surface of that molecule, and then they all packed together to form a crystal. Okay? This one here is actually bright blue. Now, if you take it, okay, if you take the copper sulfate, once again, whoops, take the copper sulfate, and we put it into our crucible, which is a bowl. Okay, so we chuck, let's just have some fun, blue, we chuck blue CuSO4, something H2O. We chuck it in there, okay? Then we come along and we heat it from the bottom, okay? We apply heat. We notice that the powder inside there, the blue powder, okay, the blue powder that's lying there turns white, gray. Okay? What has actually happened when you heat it? What does water do when you heat it? It evaporates. That's what happened. You've actually driven off that water of crystallization, right? And you've got copper sulfate, the pure powder, okay, without the water on the surface. So what they generally give us a problem like this, okay? They say, I'm just going to read it. Suppose that we heat 6.25 grams, right? Let me just write down what we're given, okay? They tell us 6.25 grams of blue copper sulfate is heated, just for fun. Okay, 6.25 grams of blue copper sulfate is heated. Okay, until we have left is a white powder that weighs 4 grams. Okay, and we get a 4 gram white powder left. All right. Okay. They say calculate the value of X in CuSO4 XH2O. This is a number of H2O molecules sitting on the surface. That's what we're looking for. All right. So first of all, what have we got? We've got blue copper sulfate. Very important. Whoops. I put green, blue. That means it's got water on it. It's blue. The water's there, right? So therefore, what have we got? We've got the blue copper sulfate. We heat it and the water goes. Let's just see what happens here. Just using a chemical equation, we've got CuSO4.XH2O. Heat. What happens? We end up with CuSO4 plus X times H2O, right? What is this about? This dot there does not mean times. It is not multiply. Not going to get that spelling right, am I? It's not multiply, okay? It means that it's actually added on. It actually is like a plus. It's just stuck on the outside, right? So when we heat it, these ones over here drift off, right? So let's say, what are we given, all right? Let's put down given. Given, they said 6.25 grams of that, okay, of blue copper sulfate is heated until we have left is a white powder of 4 grams. So therefore, plus how much water, right? Law of conservation of mass. That must add up to that. Otherwise, where did it come from? Okay, it came from the surface of this. It was stuck on the outside. So therefore, can we now work out what the mass of water was? Yes, we can. The mass of the water, let's go for blue and blue, must be 2.25 grams, because that plus that must be 6.25. Remember, we had this. Okay, I can even possibly do it a bit better. Here we go. To use something very different. Here was our copper sulfate, and here's our water, right? We had a whole bunch of these stuck on here. We heated it, these guys flew away. Okay, they've gone. But if I add what's left, plus the water that's gone, I must get back to the original, right? So therefore, we can calculate. Please note, hey, they could tell you the amount of water, then you'd just calculate that one, okay? Or they could tell you this, and then you'd go back and calculate what that is. Just put it down in that equation, write down what you're given, and fill in the blank, okay, from the equation. Okay, right, now, therefore, let's have a look, okay? Total mass, the dehydrated mass is another one. The percentage of H2O, all right, is going to be 2.25 over 6.25, right? So let's just look here, put it back to that. Percentage of water is going to be 2.25 over 6.25, isn't it? Remember, the percentage of the water that was stuck on there is that. So we have a look and we say that is going to be 36%. So 36% of it was water, all right? Okay, what's the next step? Let's look at how many moles of copper sulfate? Well, guess what? We're going back to molar mass. Always molar mass, right? Come here. Molar mass. The molar mass of CuSO4. What's the molar mass of copper sulfate? It's copper equals 64 and S is equal to 32 and oxygen is 4 times 16, okay, that is 64, 32, and 4 times 16, let's check, 4 times 16 is 64, so we add it all up, okay, and we come to 160 grams per mole, okay, right, now, what is the molar mass of water? Okay. Molar mass of water is going to be equal to H is 2 times 1 and O is 16, which is going to be 2, 16, which is going to be 18 grams per mole. Right? Okay. Now, therefore, okay, everybody happy so far? So let's put down over here our, okay, we've now got a situation where we've got the molar mass of the copper sulfate and the molar mass of the water. Therefore, number of moles of CuSO4, right, is equal to mass CuSO4 divided by molar mass. What is the mass of the copper sulfate? It was 4 divided by 160 is that. And the number of moles of H2O is mass of the water divided by the molecular mass, which was, how much was the water? The water we worked out to be 2.25. Okay, didn't we? So therefore we get 4 divided by 160. 4 divide 160 is 1 over 40. Oops, 0.025. Right? And the ratio 2.25 divided by 18 is going to be 1 over an eighth, which is 0.125. Okay, this is the ratio. Rather, number of moles, right? This is N. Number of moles, right? But the ratio, okay, is 0.025 to 0.125. Therefore, we've got copper sulfate, which was 0.025. Ratio of water is 0.125. 0.025. Sorry, let me just do that. 0.025, right? So let's have a look. What is the ratio here? divide by 0.025. All right? Divide 0.025. Okay. Is, let me just put it in here. Okay. Divided by 0.025 divided by 0.025 is 1:5. Therefore, n, or x rather, they usually use x. Whoops, sorry. Okay. 4. X equals 5. Right? Because we had 5 1:5. Right? So what you do is you work out the mass that's missing, okay, of water or copper sulfate dry or copper sulfate blue. We go to molar mass, okay, straightforward, and we work out number of moles of water and number of moles of the copper sulfate dried, and we divide by the lowest, and that gives us the ratio of X, okay? I'm going to do another session after this one, okay, where I'm going to do a few calculations where we're going to mix some ammonia and things like that, and we're going to talk about concentrations. So there will be one more. I don't think it's going to be a very long one, but I'll go through a few equations and we'll just put some numbers together and see how it works, and I'll give you that final table. Thanks for watching. I'll see you in the next one. Session 22 will be the last one. Thanks. Cheers.